So here's a video explaining the questions on the practice test for Unit 1, the very first test that we have on sections 1.4 to 1.6. Question 1, it's an absolute value equation and we need to solve it, and of course please read the instructions. It says type in the answer or answers with no spaces between your terms, separated with the word and. Okay, so let's say your answers are 7 and 13, and in this case it's an x. You're going to put x equals 7 and no space between the terms 13. If you conclude no solution, just type in no solution. So let's jump right in and do number 1. I am going to do it over here on the side. So I hope you remember that step 1 on solving an absolute value equation is to set up or to isolate the absolute value. Like there's no times 3 out here, there's no plus 7 back here that you need to get rid of. So it's already isolated. Step 1 is done for you. Then you can move on to step 2, which is to set up your positive situation and your negative situation and do a little squiggly line in between the two, all right, to separate your work. Now, how do we do the positive situation? You write it exactly the way it is without the absolute value signs. So that will be x minus 11 equals 2. And how about the negative situation? It's the same exact thing. Write it exactly the way it is without the absolute values, but you have to change the signs of the right side. Now right here we just have the number 2, so I need to change this to a negative 2. I'm going to put that negative in red so it stands out. If I would have had like a 2x plus 5, I'd have to change both the 2x and the 5. So whatever you have over here, you got to change all the signs. And of course that is after you already isolated it, but this one's isolated to start with, so we just move on to the positive and negative situation. Negative situation, change the sign of the right side of your equation. Okay, so now let's solve both of them. The positive situation, we're going to go plus 11. We'll end up with the x coming down equaling 13. And that is about it. That is a potential answer right now. I say potential because we still need to double check and make sure that it's not an extraneous solution. Now let's solve for the negative situation. Plus 11. Okay, so we have the x coming down, the equal coming down, and negative 2 plus 11, that's like if you owe $2 and you have $11, you're going to have $9 left. Okay, and this is your potential second answer. So all we need to do now is double check, all right? I usually double check in my head, but it might be a good idea for you to actually plug it in, right? So like plugging in 13 right in there. What is 13 take away 11? 13 take away 11 is 2. So what is the absolute value of 2? That is 2. So it does work out. So we just checked it, right? So 13 absolutely is a part of our answer or answers. And let's now test the number 9. 9, plug it in right there. 9 take away 11. If you have $9 and you owe $11, you're still going to owe $2. So that's really a negative 2. Let me actually write that one down. So this right here is really, when I do it, negative 2 after plugging in a 9 right here. Okay, so I still have the absolute value of that negative 2. And if I did do the absolute value of negative 2, I really do get equal to 2. So that also works. So that guarantees us that both of these are our answers. So what should we write as a final answer for this first question? X equals 13 and 9, no spaces between the terms. Now this is not, normally I would just, if it were an open response test, I would just write x equals 13, x equals 9, write both of those together. But in this case, the specific instructions say type in x equals 13 and 9, the word and, with no spaces between anything, right? No space between the x and the equal sign, no space between the equal and the 13, no space between the 13 and the a on the and, no space here either. Type it all in with no spaces, okay? So that's the answer to number 1. Let's move on. We have another absolute value equation, and of course right here we do need to simplify, we need to isolate the absolute value first. So we need to get it by itself. Imagine if this had 7x equals 56. You want to isolate the x, you got to divide by 7. It's the same exact thing. What is this saying right here? It's saying 7 times the absolute value. So in order to get rid of the multiplication of 7, you're going to have to divide by 7, and now this will be your isolated absolute value equation. So up here we have the absolute value of x plus 3. Notice I don't have the 7 anymore because it canceled out. I have the equal sign. Let me bring that down. Equals, and 56 divided by 7, that is 8. So there's my isolated absolute value equation. That was step 1. Now we can move on to step 2, setting up your positive situation and your negative situation. Okay, squiggly line in between. The positive situation is writing it exactly the way it is without the absolute values. The negative situation, same thing, x plus 3 equals 8. Nothing changes except you change the sign of everything on the right side. Everything on the right side you have to change. So that 8 has to become a negative 8. And I'm doing it in red so it'll stand up. Okay. So now we need to solve both of these, get our answers, and also double check them, make sure that neither of them are extraneous. So let's solve. We're going to subtract 3 to get rid of that plus 3. Cancels out. The x comes down. The equal sign comes down. And 8 take away 3 is 5. This is a potential answer. Let's do the other one. Subtract 3, subtract 3. Now think about this, guys. We have a negative 8, take away 3. That's actually a negative 11, right? If you owe $8 and you owe $3, you're going to owe a total of $11. So you have x equals negative 11, owing a total of $11. Now those are your two potential answers. Let's double check them. If I plug in a 5 right here, 5 plus 3 is 8. The absolute value of 8 really is equal to 8. So this guy works for sure. I just checked it in my head. Now, of course, you guys could write this out on paper if you get confused. Plug in negative 11 right there. Negative 11 plus 3. Let's think about that. If I owe $11, but I only have $3, well, I could give them my $3 and I'll still owe them $8. So this is really a negative 8. If you want to, you could use a calculator. Negative 11 plus 3 is negative 8. And then the absolute value of negative 8 really is positive 8. So this one works as well. So you would type in your answers, x equals 5 and negative 11, no spaces between your terms, right? That's how you would type it in on this particular problem. Let's move on to the next question. Another one, that's right, we have another absolute value equation, and step 1 is to isolate. So let me zoom in right here and isolate it first, and then we'll worry about the second step, doing the positive and negative situations. So imagine if you had 2 plus 3x equals 1, and you want to get x by itself. In this case, you want to get the absolute value by itself, but if you pretend it's a big giant x, what would you get rid of first? You'd get rid of the 2 first, right? And then you get rid of the multiplication of 3. So let's get rid of that 2 by subtracting 2. What you do to one side, you do to the other side. You will have 3 absolute value, x minus 7, close absolute value, equals negative 1. And then for your final step, you'd have to divide by 3, and we now have our isolated absolute value equation. The absolute value of x minus 7 equals, now I know some of us are thinking, oh, we can't divide 1 by 3. That's okay, leave it like a fraction. After all, a fraction really means division. That negative 1/3 really means negative 1 divided by 3, kind of like we have up here, negative 1 divided by 3. Anyway, do we move on and do the positive situation and the negative situation? I mean, we could, but if we did all that work, we'd get an answer, and when we'd plug them back in, they would not work. They'd both be extraneous solutions. In other words, there is no solution to this problem. How do I know that already? Because I know that the absolute value of something can never equal a negative number, okay? I mean, remember, the absolute value of 3 is positive 3, the absolute value of negative 3 is positive 3. Absolute value is the distance from that value to 0. There's no such thing as negative distance. So you can never have the absolute value of something giving you a negative number as an answer. So I could just stop right there and say no, as in no solution. Okay? And I think on this problem, you actually type in no solution. And right here, I know this might be confusing, but I think you could put it in with the space between your terms because this is how it's typed. If you conclude no solution, type it in no space solution. that should work out for you. Don't type it all in like as one word. Okay, no solution, no space solution. Okay, moving on. Finally, we get to some multiple choice questions. This is no longer an absolute value equation. This is an inequality. And we solve inequalities exactly the way we solve equations. Like if you had an equal sign right here, what would you do? You want to get x by itself. Same thing here. The only difference is on your last step, if you multiply or divide by a negative, you have to flip that inequality symbol. So we have our multiple choice answers here. Let me move over here to the side and do this problem. So here we go. The x is on the left side of this inequality. I need to get this x by itself. Obviously, it's not by itself. There's a negative 16. There's a minus 8 that's being multiplied by the x. So we need to get rid of everything except for the x. We need to isolate the x. We're going to start by getting rid of that minus 16 by adding 16, and what I do to one side, I do to the other side. I will have negative 8x is less than or equal to positive 16. And then from there, I need to get rid of that multiplication of the negative 8 in front of the x, right? After all, negative 8x really means negative 8 times x. How do I get rid of the multiplication of negative 8? I divide by negative 8. What I do to one side, I do to the other side. This will cancel out. I now have x is, because I divided by a negative, right? This was a negative 8. Because I divided by a negative, I must flip this inequality symbol. So when I bring it down, that less than or equal to becomes greater than or equal to. All right, and then over here, 16 divided by negative 8, that is negative 2. So there's our answer. Our answer is x is greater than or equal to negative 2. So if we go over here, we will see x is greater than or equal to negative, nope, x is greater than, what the heck, it's not here, which means that none of these is the correct answer, okay? None of these, okay? And I know that's kind of tricky. Usually traditional multiple choice questions have only 4 multiple choice options. In this case, you got 5, and in this case, it's none of these, right? None of these are right. All right, let's move on. We now have some compound inequalities to solve, and the only difference between a compound inequality and a regular inequality is that instead of having 2 sides, you have 3 sides. Like normally, like if I just cover this up temporarily, see, it looks like a regular inequality. If I want to solve for x, what do? I need to get rid of the minus 20 by going plus 20 and plus 20. The only difference is I'm not trying to get x by itself on the left side. I'm actually trying to get x by itself in the middle, right? So here's x. It's in the middle. You have your 2 inequalities. So whatever you do to the middle to get x by itself, you do to both outside sides. So the minus 20, I need to get rid of it by doing the opposite, plus 20. But you don't just go plus 20 there and plus 20 there. You also go out here and do a plus 20 as well. So whatever you do to the middle, you do to both outside sides. So my new problem will be, and I'm going to write it over here in blue, it's going to be a 12, right? Because negative 8 plus 20, that's positive 12. And I have the less than symbol. I have 3x. I'll write that down, 3x. And I also have another less than symbol, and 55 plus 20, that is 75. So less than symbol, 75, okay? Sorry about that. Okay, so it's all in blue. I almost have the x isolated in the middle. I now need to get rid of that multiplication of 3 in the middle by dividing by 3, and whatever I do to the middle, I do to both outside sides. So what do I have as a final answer here? 12 divided by 3 is 4. Let me ask you this. Did I divide by a negative on my last step? No, I did not. I did not divide by a negative, which means that these inequalities are not going to flip. If I were to have a negative 3 right there, then yes, we would flip them, but then you'd have to rearrange it. But anyways, in this case, you don't divide by a negative. You don't change anything. So you still have the less than. These 3's cancel out. A nice, beautiful x. Less than 75 divided by 3. There's 3 quarters and 75 cents. So that's 25 right there. That is your answer. It's a compound inequality. Type it in with no spaces between your terms. Why? Because that's what it says on the instructions. Okay. Example. Here's an example of the way it's going to look. That's kind of like how it looks. No spaces between your terms. Type it in. You're good to go. Let's move on. All right. Same exact deal. We have a compound inequality. We already know the instructions. Type it in with no spaces between your terms. I'm just going to put a giant rectangle here to show my work. First step to isolate the x in the middle, right, is to get rid of the minus 2. So I am going to add 2 to the middle, which will cancel it out. But what I do to the middle, I do to both outside sides. So put a plus 2 over here and a plus 2 over there. Negative 10 plus 2, that's negative. So I have a negative 8 is less than 4x is less than 12, because 10 plus 2 is 12. Final step, to get x by itself in the middle, I need to divide by 4, divide by 4, divide by 4. Whatever I do to the middle, I do to both outside sides. Final answer will be, what is negative 8 divided by 4? That's negative 2. Less than symbol comes down because I didn't divide by a negative. The 4's canceled out. Whoops, sorry about that. The 4's canceled out. We end up with an x in the middle. And over here, 12 divided by 4 is 3. And here is your final compound inequality answer. Negative 2 is less than x is less than 3. Let's move on. Number 7. Okay. So we have a multiple choice problem here. I'm obviously going to show the work on the side, and then we'll look for the multiple choice answer. Now here we have the absolute value and an inequality. So this is very similar to solving absolute value equations. You have to first isolate the absolute value. In other words, if you had a 3 out here, you'd have to divide by 3. If you had a plus 2 over here, you'd have to subtract 2, subtract 2. But it's already isolated for us. Let me actually redo this over here on the side. Give me 1 second. Sorry about that. Here we go. So because it's isolated, I could jump right into the positive situation and the negative situation. So the positive situation is writing it exactly the way it is without the absolute values. Everything's identical except for the absolute values. Now the negative situation, the positive is always easy. The negative situation on an equation, we used to just change the sign of the right side. We're still going to do that. We're still going to make this 5 negative. But in addition to that, we're also going to change the symbol for the negative situation. So the left side is still going to be the same, 5x minus 10. You're going to have to flip that less than symbol to a greater than symbol. And of course, change the 5 to a negative 5. So on the negative situation of an absolute value inequality, you not only change the signs of the right side, but you also change the sign of the inequality. Okay? Now let's solve both. We're going to go plus 10. That will give us 5x is less than 15. That's really 5 times x is less than 15. Divide by 5, divide by 5. I'm not dividing by a negative 5. It's just a regular 5. So that's not going to change that inequality. It's x is less than 3. That's your final or possible final answer right there. Now let's move on to the other one. I am going to add 10 as well. Add 10 as well. I end up with 5x is greater than, this is a positive 5, right? If you owe $5 and you have $10, you could pay them off, you'll still have $5 left. 5x is greater than 5. What that really means is 5 times x is greater than 5. So I need to get rid of the multiplication of 5 by dividing by 5, giving us x is greater than 1. Okay? So we have those two answers for this absolute value inequality. There is a third step to this though. In addition to isolate, whoa, that's really getting ugly. Sorry about that. In addition to isolating it, it was already isolated, in addition to doing the positive and negative situation and getting answers, we also need to go to a number line and graph our inequalities. So here's a number line. Let's put the smaller number on the left side. We're talking about the number 1. Let's put the bigger number on the right side, talking about the number 3. Obviously, in this case, the number 2 is right here in the middle. You could even do a couple more values here, 0 and 4. And let's graph this red one, which says x is less than 3. First of all, that'll be an open dot at 3, and less than is to the left, okay? It's an open dot because there's no solid line underneath the inequality, okay? So anyway, let's do the other one. I'm gonna graph this one in blue. This one reads x is greater than 1. So go to the 1. Since there's no solid line underneath it, it's not gonna be a solid dot. It's gonna be an open dot. And when I read this, x is greater than 1, or it even looks like an arrow that's pointing in that direction to the right. So this blue graph is going to go to the right. So what we need to understand here is that this is an area that's together. It's an area that's together, okay? And we're actually going to write them together. I'm going to open dot here, going all the way this way, stopping right there, okay? What this means is that your x value of this absolute value inequality, your x value, it could be the number 2. It could be 1.5. It could be 1.01. It can't be 1 because it's an open dot. It could be 2.5. It could be 2.99999, but it can't be 3. That's why it's an open dot. So your answers are between 1 and 3. So if your areas are together like this, then you're going to have to write it as a compound inequality written together with these values. And it's really easy to do that if it's already in the number line, because it's already with the smaller number on the left side, the bigger number on the right side. All you have to do is put the x in the middle, smaller number on the left, bigger number on the right, and put less than symbols, okay? Because if you did put the smaller value, the lesser value over here, and the greater value over here, then obviously the inequalities have to open up to the right, okay? Smaller values over here, greater values over here. That's why it's always less than symbols if you have your smaller number over here and your greater value over there. Now, because they're open dots, that's why we did not put solid lines underneath them. So this is your compound inequality answer, okay? One thing to note is if I would have solved this whole thing, let's go back over here. If I would have solved the positive situation, negative situation, got my 2 answers, and when I graphed them, they would have been apart. Like if this would have been x is less than 1 and x is greater than 3, if they would have been apart, then I would just keep my 2 answers, write them together with the word or between them, because that would mean it's going that way or that way. But in this case, it's together, so it's between here and here. So that means we need to write a compound inequality with x in the middle. So when we look for our answer over here on our multiple choices, it's not these guys with the word or. That implies that the areas are apart. It's this one right here, the compound inequality. 1 is less than x is less than 3, okay? Let's move on.